Hello students, in the last lecture I have discussed about the coordinate system, that is the solid geometry, where we have discussed the three coordinates: the Cartesian coordinate, the spherical polar coordinate, and the cylindrical coordinate. The next part we will discuss is the sphere definition. A sphere is the locus of point which remains at a constant distance from a fixed point. The fixed point is called the center, and the fixed distance is called the radius of the sphere. That is, a sphere is a locus of a point which remains at a constant distance from a fixed point. The fixed point is called the center, and the fixed distance is called the radius of the sphere. We'll find different equations of the sphere depending upon the conditions. First, we'll see the equation of a sphere whose center is at ABC. That is, the center is at ABC and radius is equal to R. Then, by using the distance formula, we have x minus a bracket square plus y minus b bracket square plus z minus c bracket square is equal to r square. So therefore, x minus c bracket square plus y minus b bracket square and z minus c bracket square is equal to r square represents an equation of a sphere passing through the center ABC and having the radius r, and we have taken any point on that sphere is equal to p of x, y, z. For the distance of a point p, x, y, z on the sphere from the center ABC is equal to radius r. In particular, if the center is at 0, 0, 0, that is, it has the center at the point 0, 0, 0, then substituting a equal to 0, b equal to 0, and c equal to 0, we get x square plus y square plus z square is equal to a square. Sometimes this equation x square plus y square plus z square is equal to a square represents an equation of a sphere and is called the standard equation of a sphere. So this is an equation of a volleyball. Volleyball is a sphere. Its equation is given in the form of x square plus y square plus z square is equal to a square. Then we'll see the general equation. The equation x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0 represents the general equation of a sphere whose center is at minus u minus v minus w and radius is equal to square root of u square plus v square plus w square minus d. So this is 2ux minus half of the coefficient of a is equal to minus u minus of half of the coefficient of y, that is minus v, and minus half of the coefficient of z, that is minus w, is the center, that is in the last part. This was at ABC. That means that ABC are now replaced by minus u minus v minus w, and radius is equal to square of these central points, and then minus the, you are having plus d, then take the minus d of this value. Then for the equation can be written as, so this is x square plus 2ux, this is y square plus 2vy, and this is z square plus 2wz are combined, and this d is taken on the right hand side, that becomes equal to minus d. Then this can be adjusted with squaring this value. Then when you square this value, you get x plus u square. Then here you get plus u square. This has to be again subtracted, and this subtraction goes on the right hand side, becomes u square. Similarly, v square and w square. is equal to u square plus v square plus w square minus d. And comparing this equation with x minus a bracket square plus y minus b bracket square plus z minus c bracket square is equal to r square. That was equation of a sphere passing through the center A and ABC and the radius R. Then if I compare this value, you get this becomes minus A equal to U. That means U is equal to, that is equal to minus A. Similarly, phi is equal to minus B and W is equal to minus C, which clearly represents an equation of a sphere whose center is ABC. That already we have seen. The center of this sphere was ABC. If I compare this with this, then I get minus U minus V minus W. And this is R square. So this is R square. R is equal to square root of this value. So therefore, R is equal to under root of U square plus V square plus W square minus D. Thus, the general equation of a sphere is such that it is the second degree in xyz, because you are having x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. It is a second degree in xyz. Then the coefficients of x square, y square, z square are equal, and there are no terms containing xy, yz or zx. So there are no product terms of this xyz. Then we'll go to the next part of this. That is, the section of a sphere by a plane is a circle. The section of a sphere by a plane is a circle. And the section of a sphere by a plane through its center is called the great center. So this is important. As far as the great center is important. What is that great center? The section of a sphere by a plane through its center is called the great circle. So thus the equations. What the equations? This is an equation of a general equation of a sphere, x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. So this is an equation of a sphere. And then this is ax plus by plus cz plus d equal to 0 is the equation of a plane. Then these two taken together, that is the equation of a sphere and an equation of a plane taken together represent a circle having the center at L and radius having the center at L and the radius LA, this LA. So if you see this becomes a right angle triangle, then this LA is equal to square root of, so this becomes equal to R square minus P square. So therefore, this represents the equation of a circle. That is, these two taken together becomes an equation of a circle. Then we'll see the equation of any sphere. So this is the next part. The equation of any sphere through the circle of intersection of the sphere S is equal to 0 and the plane U is equal to 0 is S plus KU is equal to 0. So S is equal to 0 becomes an equation of a sphere equated to 0, and U is equal to 0 becomes an equation of a plane equated to 0. So therefore, the sum and product of this is equal to 0. That is, S plus KU is equal to 0. For again, because the equation S plus KU is equal to 0 represents a sphere, and the points of the intersection of the sphere S is equal to 0 and the plane U is equal to 0 satisfy it. Now we consider some examples on the sphere. First example, find the equation of the sphere through the 4 points 0, 0, 0, 0, 1, minus 1, minus 1, 2, 0, and 1, 2, 3. Locate its center and the point, find the radius of this. Now we'll have to find an equation of a sphere which passes these 4 points. That means the sphere which you are going to find has to pass through these 4 points, in which 0, 0, 0 is one of the points. Now to find the equation, now actually if you see the equation of a sphere which contains x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0, it has actually 5 variables. Which are the variables? U, v, w, d. Okay, so therefore here you are having u, v, w and d, the 4 variables. You want to find these variables and put that values, then substitute that values in this equation back, then whatever you get, that becomes the equation of the sphere as it passes through the points. This equation, now we started with the solution, the required equation of the sphere B. Now we have taken this as a, it may be the general equation of a sphere in which you are having 4 variables u, v, w, d. You want to find them. This can be found by using the 4 points as it passes through the points 0, 0, 0, 0, 1, minus 1, 2, 0, and 1, 2, 3. It must satisfy the equation. So these points have to satisfy the equation. So at the first point 0, 0, 0, we get x is 0, y is 0, z is 0. So all these become 0. Therefore you get 0 plus 0 plus 0 plus 0 plus 0 plus 0 plus d equal to 0, implying thereby d is equal to 0. So therefore the point 0, 0, 0 has given us one variable, that is d is equal to 0. So one variable is known to you, d is equal to 0. Then we'll take the second point. What is the second point? At 0, 1, minus 1, that is x is equal to 0, y is equal to 1, and z is equal to minus 1. The equation becomes 1 plus 1 plus 2u minus 2w is equal to 0. That implies 1 plus 1 is equal to 2 plus 2v minus 2w is equal to 0. That implies, because d is already equal to 0, therefore this part is equal to 0. Then this implies, that is 2 is taken outside, this becomes 1 plus v minus w is equal to 0. Okay, so this is an equation where you are having the two values. You are having two values that are v and w. These are the variables. Then this is a constant. Then we'll take the next point. At the next point, minus 1, 2, 0. That means at x is equal to minus 1, y equal to 2, and z is equal to 0. Again, when you substitute this equation, you get 1 plus 4 minus 2u plus 4v is equal to 0, implying thereby this becomes 5 minus 2u plus 4v is equal to 0. This implies minus 2u plus 4v plus 5 is equal to 0. So this is the third point. Then at the last point, that is 1, 2, 3, you get, again put the values of x is equal to 1, y equal to 2, and z is equal to 3. Then you get the corresponding equation, and again that d is equal to 0. Therefore we get, this becomes 14 plus 2u plus 4v plus 6w is equal to 0. Then 2 is common, you can cancel throughout. Then you can get this value is equal to u plus 2v plus 3w plus 7 is equal to 0. Then we have to solve these three equations 2, 3, 4 simultaneously for finding the values of u, v, w. Now to eliminate w from 2 and 4, now this is equation number 4, and from equation number 2 we have to multiply equation number 2 by 3 and add to equation number 4, that is 3 plus 3v minus 3w is equal to 0. That is taken from equation number 2 and multiplying that equation number 2 by 3. Okay, then this is your fourth equation. u plus 2v plus 3w minus plus 7 is equal to 0. Now you are adding these two equations. So this minus 3w plus 3w will get cancelled. Then this becomes 5v and this becomes, that is equal to 3 plus 7 is equal to 10. So u plus 5v plus 10 is equal to 0. Then again from equation number 3 we have minus 2u plus 4v plus 5u is equal to 0. Multiply 5 by 2 and add the result to equation number 3. So you get this equation becomes 2u plus 10v plus 20 is equal to 0. Then you get this equation is minus 2u plus 4v plus 5u is equal to 0. Then when you take the solution of this, so you will be having this becomes 10 plus 4 is 14v plus 20 plus 5 25 is equal to 0, implying thereby phi is equal to minus 25 upon 14. Now this is the another variable. One variable d is equal to 0. Then we got the second variable phi is equal to minus 25 upon 14. Then from equation number 5, we have u is equal to minus 5v minus 10. That is minus 5, phi is known to you, minus 25 upon 14, then minus 10. Then simplify this value, then you get this equal to 125 minus 140 divided by 14 is equal to minus 15 upon 14. So therefore, another variable u is known. U is equal to minus 15 upon 14. Then w is equal to 1 plus v, that is from equation number 2. Therefore, w is equal to 1 minus v. V is equal to 25 upon 14. This goes on 14. Then this becomes minus 25 divided by 14 is equal to minus 11 upon 14. Therefore, this is the fourth variable. W is equal to minus 11 upon 14. So u is equal to minus 15 upon 14. Phi is equal to minus 25 upon 14. W is equal to minus 11 upon 14. And D is equal to 0. Then substituting these values in the equation 1, that is the required equation of a sphere, we get the equation of a sphere as x square plus y square plus z square. Then you are having minus that 15 upon 7x minus 25 upon 7y minus 11 upon 7z plus d, that is equal to 0. Therefore, minus 11 upon 7 into z is equal to 0. This represents an equation of the required sphere which passes through the 4 points. Then we want to find its center. That is, the center is minus u minus v minus w. That is 15 upon u v w are known to you. This is minus u will go on this side, becomes 15 upon 14, minus v becomes 25 upon 14, and minus w is equal to 11 upon 14. And its radius is given by, you'll have to go back to the formula, square root of u square plus v square plus w square minus d. That is square of this value, square of this value, square of this value. D is equal to 0, becomes is equal to square root of 971 divided by 14. This becomes the equation of a sphere which passes through the 4 points and having the radius and the corresponding center at the points 15 by 4, 25 by 14, 15 by 14, 25 by 14, and 11 by 14, and the radius is square root of 971 upon 14. So these questions are lengthy questions. When they come in the examination, you can get 6 marks for finding the equation. Then we'll see the second example and then we'll stop. In the next period, I'll go for the next type of the questions on finding the equation of the sphere depending on the given conditions. The second equation is find the equation of the sphere which has x1, y1, z1 and x2, y2, z2 as the extremities of a diameter. That means you are given a diameter which has the points x1, y1, z1 and x2, y2, z2. That is sometimes called the diametric form of an equation of a sphere. Then also deduce that the equation of a sphere described on the line joining the points 2, -1, 4 and -2, 2, -2 as a diameter. That means this is general equation. This is a particular equation. That means put x1 is equal to 2, then y1 is equal to -1, z1 is equal to 4, and x2 is equal to -2, y2 equal to 2, and z2 is equal to -2 as the diameter. Then the next is find the area of the circle in which the sphere is intersected by the plane 2x plus y minus z is equal to 3. Okay, so this is the third equation. That means you are given three problems in one problem. This is the main problem. That is, you are finding the general equation of a sphere which is in the diametric form. Then a particular equation for finding the equation of a sphere having the diametric points as x1 y1 z1 and x2 y2 z2. And this is the third problem in which you are having find the area of the circle in which the sphere is intersected by the plane 2x plus y minus z is equal to 3. So we'll solve step by step. We'll see the first one, that is, let pxyz, now this is pxyz, be any point on the sphere. Now this is a sphere. Okay, then pxyz is any point on the sphere. Then this is a diametric form, that is a x1 y1 z1 and b x2 y2 z2, having a x1 y1 z1 and b x2 y2 z2 as end of the diameter. And this is the end of the diameters. Then AP and BP. So this is AP and this BP are perpendicular, are at right angles. Now there is a direction ratios of AP. That is, the direction ratios of this point are the difference between the coordinates, that is x minus x1, y minus y1 and z minus z1, and those of BP. Okay, those of BP are x2 minus x1, y2 that is x minus x2, y minus y2 and z minus z2. Okay, these are the direction ratios of BP. Then these are the direction ratios of AP. x1 x minus x1, y minus y1, z minus z1 are the direction ratios of AP, and x minus x2, y minus y2, z minus z2 are that of BP. Now, by using that formula, what is that? The product must be equal to the product of these direction ratios must be equal to 0, because these AP and BP are perpendicular to each other. Therefore, by applying that formula, we have x minus x1 into bracket x minus x2 plus y minus y1 into bracket y minus y2 plus z minus z1 into bracket z minus z2 is equal to 0, which is the required equation of the diametric form of a sphere. That is x minus x1, x minus x2 plus y minus y1, y minus y2 plus z minus z1 into z minus z2 equal to 0 represents an equation of a sphere passing through a diametric form where the ends of the diameter are x1, y1, z1 and x2, y2, z2. Therefore, we'll just put x1, y1, z1, x2, y2, z2 as these points 2, -1, 4 and x2, y2, z2 equal to -2, 2 and -2. So substituting these values, you are having this becomes x minus 2, then x plus 2 plus y plus 1, y minus 2 plus z minus 4 plus z plus 2 is equal to 0. Now, if you simplify this equation, you get x into x is x square. Then this is 2 into minus 2, that becomes is equal to or a minus b, a plus b is a square minus b square, x square minus 4. Then this is y into y is y square. Then minus 2y plus y is minus y, and minus 2 plus 1 equal to minus 2. Then this is z into z is z square. 2 into, that is 2 into z minus 4z is minus 2z, and minus 4 plus 2, that's a multiplication, is equal to minus 8 is equal to 0. So this becomes x square plus y square plus z square minus y minus 2z, then minus 14 is equal to 0. This becomes equation of a sphere having the diametric forms at the 2 points. Then the last one, the if you see the center of this is given by minus half of the coefficient of x. There is no coefficient of x. Centers becomes is equal to 0 and half of the coefficient of y, that is plus half, and half of the coefficient of minus half of the coefficient of z, that is 1. And this becomes the center of this sphere, and the radius of this is given by square root of 1 by 4 plus 1 plus 14, that is equal to under root of 61 upon 4. So the center and radius of this diametric form of a sphere are known to you. Then by using this, you want to find the next, the area of a circle having the plane cutting this sphere by the plane 2x plus y minus z minus 3 equal to 0. So let the given plane 2x plus y minus z minus 3 equal to 0 cut the sphere x square plus y square plus z square minus y minus 2z minus 14 is equal to 0. Then in the circle at P dash, okay, having the center L. Now this is the center of the circle having, that is equal to P, and P dash becomes the circle whose center is at L. Then P is equal to, this is P, this is equal to L and C. Now C is the center of the sphere, L is the center of the circle. Okay, then C is already known to you, which is equal to at the point 0, 1 by 2 and 1. P is equal to perpendicular CL from C on the plane 2x plus y minus z minus 3 is equal to 0. So therefore, using that formula, we get P is equal to 1 by 2 minus 1 minus 3 divided by square root of the coefficient of this x is equal to 4, the coefficient of this y is 1, and the coefficient of z is this 1. So therefore, the product of this is equal to 7 upon 2 root 6, that is in the magnitude. Then if A be the radius of the circle P dash, then A square is equal to R square minus P square. Now the radius is given by 61 upon 4, and P square, we have found the value of this, 7 square is 49, then square of this becomes 4 into 6 is 24, and the value of this is equal to 317 upon 24. Hence the area of the circle is pi a square, that is you are having pi a square. Now a square is known to you, this is a square, 317 upon 24. So therefore this becomes 317 upon 24 into pi becomes the equation of the area of the sphere. By using that, that means it contains 3 problems. We have solved one problem, we have solved 3 problems, which contains a plane, then the area of the circle, then finding the equation of the sphere, and all this. So in the next video, I'll share you some of the problems on the sphere, and we'll continue for the last part. Thank you.